Well, thanks again for coming out to talk about the Amazon Elasticsearch service. I'm not going to go too salesy on things, and I'm going to dive into some use cases and some architectures and other things that I think I find interesting and you might find interesting. I'm also going to share some labs that we've done before, and these show how we can integrate DevOps with Cloudformation to create environments. And then I'll share some Java code with you that we'll show you how to connect to the Amazon Elasticsearch service using the high-level REST API. And all that sort of blends into a lab that I'll share with you. Feel free to use it. If you don't have an Amazon Web Services account, you can sign up for one for free, and this lab will work in the free tier. All right, so I'm going to make sure I don't feedback here. So my name is Kevin Fallis. I'm a Senior Specialist Solutions Architect with the Amazon Elasticsearch service team. And today we're going to be talking about the Amazon Elasticsearch service. And Bob Taylor also has joined us. He's out with me for the next 4 days here in lovely Stockholm. And we'll be spending time with people out here. So if you have any questions on the service, feel free to ask us questions. And also, we have Frederick with us.
Yeah, I'll introduce myself quickly. So super excited to be here. My name is Frederick Eriksson. I work at AWS here in the Nordics. So if there's any questions just on how we support customers or anything related to the Nordics, I'm super happy to answer any of your questions.
All right. So let's kick it off. Quick agenda. So today we're going to talk about the Amazon Elasticsearch service and specifically the components that comprise this. And then later on we're going to look at different ingest patterns and other patterns that many customers leverage to effectively communicate with the service. Additionally, we're going to look at a new project. Many of you might have heard about Open Distro. So Amazon is supporting an open source community now with our Open Distro for Amazon for Elasticsearch. And so many of the things that you see with our service are now going to be built from this breeding ground of community-based developers. So in time, we hope that this community will get larger and people will contribute and we make better products. And finally, I'll open up the Q&A in the end. So what I have, and we don't have to jump into this, but I always like to come to a session and have some toys to go home and play with. And this one particularly is a concept where many people like to take databases and use that as their source of truth. But if you use things like DynamoDB or if you use regular relational databases, to get that searchy kind of flavor, you have to use indexes. And building all these indexes to try and get across, and query all that data, sometimes will take a lot more resources and management resources, whereas Elasticsearch fulfills that bill. So what we see is hybrid environments. And with these hybrid environments, people are basically moving the indexing and search capabilities off to Elasticsearch and letting their source of truth databases manage the whole transactional activity and the other maintenance they need to run their applications. So this will show you how that interaction will work with DynamoDB. It uses DynamoDB streams, and actually let me pull up a real quick picture here so you get an idea. So what this in particular will do is it uses a combination of serverless and also the Amazon Elasticsearch service. And the idea here is that we're going to place some data on S3. Then Lambda is going to take this information, it's going to hydrate it into DynamoDB table. Additionally, we're going to use Amazon's Cognito, which is basically a security service. So we look at this as like an identity pool where you can have users and give them permissions to look at Kibana, which is a service feature for Elasticsearch. And then what will happen is that as you add data into DynamoDB, we'll use DynamoDB streams to put the context and the metadata into Elasticsearch. And so this whole cycle repeats itself every time you add a record into DynamoDB. We'll get an update record for Elasticsearch. We'll either add or update a record in there. And then now you can search on multiple different facets. In this case, it's going to be a movie database. And then you can find the things that you're looking for. And so that lab that in those links, and I'll share those here in the end, will give you the ability to explore this and see how that service or those combination of services work. All right. Wrong page here. Okay. So also down at the bottom, I have an Eclipse Maven project too. If you want to crack that open, it has some source code that shows you how to use Java's high-level REST API and use that to interact with the domain. All right, so we'll talk briefly about the use cases, what people use Elasticsearch for. So many of you might have a store, or people might have a business where customers want to come to it and search information. So this is a search use case, and I would say that there's two high-level use cases that the service really supports or has a lot of adoption, and that being search and also log analytics. So in the search activity, your customer base wants to explore different products, and so the Elasticsearch service provides you multiple different ways to look at that data, analyze it, and give your customers information on the things they're looking for. So if you want to say, I want to find all houses, if it's a real estate activity, I want to find all houses within, say, 5 miles that have 3 bedrooms, 2 baths, and they're very close to work. So this is a great search use case for Elasticsearch, and this is where we see many people using that engine to do that activity. Next we have is log analytics. Now, log analytics covers a broad range of things, but mostly we see people taking server logs, and such as access logs, sys logs, you name it, application logs, and they're putting those into Elasticsearch. So again, log analytics is a really good use case for Elasticsearch. Also, on a side note, we also are seeing a lot of people starting to use, a lot of these connected devices, the IoT platform, right? And when you're using the Internet of Things, there's you not only have the customer metadata. So let's say that you have information about, maybe a sensor in your house that's keeping track of the heat and the cooling. Now, the customers may want to explore this, but also as an operational team, you want to understand how that fleet is acting and how it's operating. So you'll see this as a mixed use case where I present a product. Not only do I do the search, but I'm also doing log analytics against the data that's being presented through those devices. So how many of you are familiar with Elasticsearch itself outside of our service? All right. And okay, so what we basically do for Amazon Elasticsearch service is we take the open source, the Apache 2.0 license that's out there, and we bring that in and we manage that as an offering to you. So we don't create anything different out of the Elasticsearch code base. What we do is we provide a means by which you can deploy these services really easy. So let's face it, if you've stood up very, very large Elasticsearch clusters, you always have to deal with the fact that things will fail. And you can automate this. A lot of times, sometimes you can't automate it. And you might have to get in there and alter things or up and have it running properly. So our service actually manages that ecosystem for you. It provides a support team, a vast support team globally, and it provides the means by which we can deploy different Elasticsearch clusters based on your needs. Through automation. We'll talk a little bit more about that. So we support APIs in the open source tools that are out there. So Elasticsearch has, specifically its own APIs, and there's a broad range of things that have been built for people to go ahead and interact with the cluster. So just like you would have with your own homespun vanilla Elasticsearch instances, we provide those APIs and tools to help you manage it and also interact with the cluster itself. It's really easy to use. We can spin these clusters up on the order of minutes, and basically an endpoint gets presented to you for the search and for the Kibana visualization. And in the end, you have a fully running domain that can then house your data and you can interact with it. It's very scalable. So what I mean by scalability is that you can scale up vertically, or you can go horizontally. So if you need more horsepower for your JVM, you can have an instance family on AWS that has more capabilities, more memory, more CPU to give you that added horsepower for your indexes. Also, we can scale wide. So we can go up to 200 instances on a domain, roughly 3 petabytes of data for each Elasticsearch domain. And so imagine having this capability at your fingers, everything's taken care of you from a management perspective, and I have an Elasticsearch cluster that can house a lot of data if I want to. From a security perspective, we have some integrations with Cognito that allows you to use maybe third-party identity providers such as Okta, Ping, Active Directory, and other identity providers. But a Cognito federation with Elasticsearch essentially allows you to lock down your domain. And so using identity and access management on AWS, we can lock that down so that you can have a secure domain. Also, we are using encryption at rest and encryption in transit, and these things are features that you can put on there. Highly available, multi-AZ, and tightly integrated with a lot of other services, and I'll talk about that in a second. Right, so real quick, high level, for those that have not used Elasticsearch, you can think of it as a database. It's not truly a database in the ACID sense, but it allows you to put data, and effectively you can put the data into Elasticsearch, and then you index these things as fields in documents. And once you've indexed the documents into Elasticsearch, those fields become searchable. Then you can go ahead and query this data and bring it back. I can make changes to the data, just like I would on a database. These things are eventually consistent, but effectively I can write my documents, and then I can then query the data that's associated with those documents. So if we peer underneath the covers on the service, typically if you're running your own, you're basically be running, say, on-prem or using your own EC2 instances, or maybe some virtual machines or even containers, even Kubernetes. But what you effectively have behind the scenes is that we present a management console or a command line interface or our SDKs or Cloudformation to go ahead and stand up the cluster. So there's a broad range of tooling for the Amazon Elasticsearch service that allows you to spin that up and deploy the domain. So behind the scenes, what happens is that the service will create what is called a service VPC. And before I go too deep into the geek acronyms for AWS, everyone's familiar with VPC and some of these terms? Great. Okay, and so what we'll do in whatever region you pick, we'll stand up a service VPC behind the scenes. It's isolated. Only your instances are going to run that VPC. Effectively, we're using identity and access management to control the domain or IP whitelisting. But this is all in the form of basically a domain policy, which is interrogated when the request comes in. After that, we use a load balancer to go ahead and deploy the request to the data nodes. And so in Elasticsearch, there's a concept of master nodes and data nodes. And there's a couple of the different node types out there. From the service perspective, we deploy data nodes and master nodes. Master nodes contain the state of the cluster. Data nodes code your data for your indexes and the shards that are distributed on that. In the end, we can monitor the cluster with CloudWatch, and we can also use CloudTrail to understand who's been using the service or who's been interacting with the service to make changes and things like that. Finally, from an ingest perspective, we have a Kinesis data firehose. So you can take a stream of data. It has a Lambda transformer on the end, and it automatically talks to Amazon Elasticsearch service. And so right to the index that you specify, and it's a really easy way to get data into the service. And just recently, we've announced that to be within VPC, so you can now use this pattern for your private deployments if you want. Also, there's a integration with CloudWatch logs. And CloudWatch logs will be able to take all of your log files on AWS that go into CloudWatch and allow them to be presented to you in Elasticsearch format, so you can query it and understand trends and other activities. All right, so we talked about the search use case, and so let's kind of look at a pattern around search. So in this case, let's say that I have Iron Man and I'm searching for particular movies. What would I actually have for an architecture? So common patterns are for people to create like a static website or some static content to represent their website. This gets housed on Amazon CloudFront. And then your page information or the dynamic stuff will then be coming from EC2. It can also be used as a source too for a CloudFront distribution. And then some customers will actually have application servers on EC2, or you could have also containers or things along those lines. But in the end, typically you see a database, which will be a main catalog or a source of truth, where I'm doing my business operations. And then I might have some high velocity inventory clicks or other things I want to track about users and have those presented as dashboards. So we see sometimes a broad range of folks using DynamoDB also to surface some of that data. And in the end, I can index some of this information in RDS and DynamoDB and have basically quick application content search by coupling these services together as I go down the line. So this is what a typical flow would look like for a search activity. I'm putting data in from a variety of sources, or one source, and then I'm pulling that data back. It's a bidirectional activity. The next use case I talked about was log analytics. And with log analytics, effectively you're going to have data producers, and then we're going to store this in some sort of collection. And when I talk about collections, a lot of times we like to think of patterns where we decouple the actual Elasticsearch service from the data producers. And the reason why we do this is that you may want to change things. We may want to take something down for maintenance, or other things that highly coupled environment would potentially cause outages. This might give us a better way or a better pattern to control the ingest going into Elasticsearch. And so what we see from a collection perspective, and I'll talk a little bit more about this in some follow-on slides, but you'll have a broad range of things you can collect on. Kinesis streams, Kafka, Redis, or even using S3 as a source to hydrate things. And then, a lot of customers will then keep that data in S3 for longer-term analysis, where the hot data is brought into Elasticsearch. We'll transform that data before we ingest it in, and then we'll present it to the Elasticsearch service. And then if you have data sitting on S3, there's a broad range of other services that can actually interact with that data on Amazon Web Services, such as Athena, EMR, Redshift, and of course even the Elasticsearch service. All right, so let's change it up a little bit here and talk about some common patterns for log analytics. Out of the people here in the room, how many of you do log analytics? All right. And so the concept I'm going to talk about is probably not new to you. But effectively, when you look at search use cases, a lot of times you're dealing with fixed indexes. And log analytics present a different problem because we have data that's coming in on a frequency. And what you want to do, if I just continue to allow these indexes and this data to keep on getting larger and larger, I'm going to start paying more for my cluster. I'm going to have a larger cluster. And potentially over time, I'm not going to have more room in it. So a common pattern is to go ahead and age or roll indexes. So with Elasticsearch for log analytics, effectively we would create a daily index. And as my oldest index rolls out of my sliding window, say it's 7 days or 21 days, I'm going to go ahead and drop that index after saving it. And so a pattern would look like, I would have an alias. And how many people are familiar with what aliases are in Elasticsearch? Okay. So an alias basically is a high-level representation of a combination of either one or multiple indices. And when I talk to the alias, that will allow me to be basically a proxy to talk to the indexes that are associated with that alias. Well, what I can do if I'm doing a sliding window is that when my new day starts, I create a new index. I adjust my alias to allow that new index to come in. I take my oldest index, I go ahead and remove it from the alias. And then using Curator and a couple other tools in the Amazon in the Amazon ecosystem, I can then go ahead and snapshot that data and then go ahead and drop the index. So if I know that my data is sitting at, I call it terminal state, but let's say if you're doing a terabyte of data a day, you have a 14-day window, you have 14 terabytes of data. And effectively, that data doesn't really change too much. It might go up, it might go down some, but if I use a rolling index construct, then I can basically save space, and I can focus on the data that I'm really interested in searching on for a short-term activity. So this walks you through how you do that. I basically create the new index, adjust the alias, and add the new daily index. I remove the old index out of the alias. I go ahead and manual snapshot it, and then drop the oldest index. And that allows me to preserve a fairly statically sized Elasticsearch cluster for log analytics. All right, some of the other patterns that are coming out are basically lake catalog search, or data lake catalog search. And, real cool serverless thing that has come out of this activity is that when you drop files on S3 and you set up S3 bucket notifications, which is a feature that you can set on an S3 bucket, I can trigger events. And these events can either go to SNS, which is a simple notification service, SQL, which is a simple queuing service, or it can directly fire a Lambda. And so what's nice about this is, with a matter of clicks, I can start dropping files onto S3. We'll pick this up, it will fire up a Lambda, and as long as I have the right client code in my Lambda, and I can parse that file out if it's gzipped or whatnot, I can then pull that in and index it in Elasticsearch. And this is probably the most simplest use case, for getting data into Elasticsearch. But what this allows you to do is that if you have your data ordered in appropriate locations, and if customers are dropping those files, you can almost isolate those buckets based on customers, and you can start building metadata up. And the metadata you'd be serving, it could be stuff that's passed in the request headers when you're doing your HTTP put to S3, or it could be some other data that's just metadata that you've hung with the data that you're putting in there. But the idea here is that I get a bucket name and a object ID, or the key, and the two of those basically present me a URL. So you put your metadata in a URL, and now you can search for information about what those files are. The next activity, infrastructure monitoring. And so there's a couple different flavors out here, but these are the most common ones that we see. So first, if we look to the Elastic ecosystem, we have what's called file beats. And who's familiar with the beats ecosystem? All right. Well, just to give you a high level on it, they're lightweight producers that allow you to specifically focus on a use case, such as I might have a beat that gives me information about CPU utilization and other things on a server. There's another one that is a file beat, which basically reads files locations and will put it to a destination. In this case, you could use Redis, and I'll talk through some other ones here. But in the end, once you've cached that data up in that collection, then we use Logstash, a fleet of Logstash indexers, to read from that queue or that collection and to put that information into Elasticsearch. Another flavor of that, some people call it EKK, which is Elasticsearch Kinesis Kibana, but there's still some other things in there that you still got the elk part, right? Because you're still using Logstash, but we're also introducing something else, which is FluentD. FluentD, a similar approach to Logstash. I can have input plugins and output plugins, which allow me to specify my source and my destination. But in this case, we could use FluentD to then talk to Kinesis. And Kinesis is a managed stream on AWS, and Kinesis data streams in particular allow me to have my own consumers using a Kinesis client library and a Kinesis producer library. And the combination of that allows Logstash to actually read from the stream and write to Elasticsearch. So that's another pattern that we see out there. Finally, if we talk about infrastructure monitoring, people like to do a lot of security activities, right? And another lighter use case out there is being able to search for specific pieces of information. And we sort of, spread this one around a bit, but, typically what you're going to see is typically what you'll see is that we have many different producers. They could be containers. They could be even Lambdas that are firing off things to CloudWatch logs. Anything that can produce logs are things that people from a security perspective might want to interrogate, right? You might want to say, over this time period, how many times has this IP address been talking to my application? What are they trying to do? Are they trying to crack into my Apache host? And so, you have a broad range of things that you could use, but another buffering solution out there is managed service for Kafka. And Kafka allows you to have not only hot patterns or Lambda architectures, but also look at colder data. And so we'll find, between the Kafka, the Kinesis, and even EMR, where I can act upon the data that's on S3 if I'm bringing it in and storing there. This gives me multiple different solutions that I can leverage depending on the use case to go ahead and write to Elasticsearch. Another thing too is container monitoring. So we just recently had a lab for reInvent for this one. But effectively we're using metric beat and fluentd to capture information about not only the containers that are running on the container ecosystem, but also the things behind the scenes. So if we're using the the Amazon Elastic Container Service, then effectively there are metrics and other things about the ecosystem that you might want to capture. So you can tie the two together by capturing the logs on the instances and capturing the ecosystem that is supporting those containers. All right, so I'm going to pause here for a second, and from the architectures that you've seen so far, have any of you gotten other architectures that you prefer or like to use? What other type of streaming activities or things would you use for a collection or a buffer? And if these are pretty typical, go ahead.
SQS and Lambda in front of Elasticsearch and bulk insert on relatively small clusters of Elasticsearch, because bulk operations work much better rather than a lot of parallel small operations. So that usually takes down the size of a cluster from relatively large instances and many instances in parallel to probably just one really small.
Yeah.
You can still you can insert over there as much as the memory would allow you, but it works very well for a few gigabytes of data, I guess, in total in indexes.
Yeah, and that is a good pattern. There's actually I have a little project off to the side I'm working on right now, and I'll probably share that code too. But I've always thought about SQS seems like a very, very cheap option, right? I think you get 1 million messages per month, right? Something like that in the free tier?
1 million operations.
1 million operations.
Yeah.
And so, given that, there's a lot of stuff that you could offload to the free tier over the life of that application. And what's really cool about it is in that earlier architecture where I showed event notifications, I can event notificate to SQS. SQS has the objects of the files that you need to crack open. Then you have a Lambda that picks up off the SQS stream because there's a direct integration to that. And then the Lambdas will fire, crack open each one of those objects. You write the code to then push that into the Elasticsearch cluster. And you can use the Java high-level REST API to do that. So that's definitely a great pattern, and I probably need to put that into the deck too, but thanks for that. Okay, so I'm going to walk you through, typically what a network stack is going to look like. And I actually have another lab that I will also share at the end here. 3 links, 3 URLs. Make sure I get them up on the screen later on. But I'm going to talk to you, typically what you might see for a logging solution. And so to begin with, we like to think of high availability on AWS. And Amazon Elasticsearch Service gives you that ability to choose one AZ or multiple AZs. And in these availability zones, it allows me to spread my cluster in such a way that if I incur a failure or issues with one availability zone, I can use the other availability zone to pick up and keep my traffic going. And by using the right sharding strategy, I can still have a cluster that stays alive to do my work for me. And so we like to deploy typically in multiple AZs. And usually you have a public subnet and a private subnet. The private subnet is where you're going to keep all your data secure and firewalled off from the rest of the world. Public subnet is where you're going to incur, any other attacks or things that might come in there, but you can still preserve your data. And looks like my WinZip is out of date. So, off to the right, it's just an abstraction. So when I talk about service VPCs, they're also highly available themselves. But I'm not going to go into a great amount of detail here on what that looks like. So a lot of times you'll stand up some sort of access. You might have a NAT gateway, or you have an internet gateway to get information. NAT gateways are good if you have to do updates. You can use that as a proxy to firewall off things in your private subnet and still have some sort of access to maybe a public repository. And yes, I understand that I have zip files. All right. And so the next thing that we look at introducing is effectively a buffer. So I talked about maybe Kinesis data streams as being one of those patterns. Now, when we start talking about private subnets, one of the cool things about the services is that we have ENIs. And ENIs are elastic network interfaces that get stood up in your own private VPC. And they give you private IP addresses. They're not publicly addressable. So when you deploy Kinesis, when you deploy Amazon Elasticsearch service, and there's a multitude of services that actually have these ENI capabilities, what it'll allow you to do is build an end-to-end secure solution. And so once I stand up Kinesis data streams with private endpoints, then I can go ahead and put Elasticsearch. Elasticsearch itself has private endpoints, or ENIs that get presented into your VPC. So when I start communicating with these things, I would have to actually get in through potentially a portal, or some people call these bastion hosts, or there's other names for them. But the idea is that here's a public zone that I can log into with SSH, and then I can go check things on my Elasticsearch cluster, admin APIs, or things like that if I wanted to. So then when you start building your solution, if we look at these servers over here, they would be called indexers. And so their job in a private space would be, I'm going to read from a Kinesis data stream, I'm going to pull that across the network interface, now I'm going to write it back out to Elasticsearch. Again, all this is on a private network. Then the next thing you have is your application logic. So typically an application can be behind some sort of a load balancer. In this case, it's an application load balancer. And I'm able to direct portions of my application to fleets of servers as I need for my scale. Again, my application is in the private subnet. I'm using auto-scaling to scale those out. And now this gives me pretty much a full round trip of mechanisms that I can use to have a private domain stood up and have most of my application kept into the private scope. And what's really cool about all this is that we can use Cloudformation to spin these environments up. And so, in practice, you can stand up an entire end-to-end solution using Cloudformation with Amazon Elasticsearch service and have a fully presented, working solution that could, serve data or even capture that log data and put it back into the Elasticsearch cluster. So, I can share these slides here afterwards too, but these are kind of the things that we think about with the service, and using the surrounding services on AWS, such as Cloudformation, gives you a high level of control of your environment, and really allows you to think of new applications at a higher level. So some of the new things with the service is, I did talk about Open Distro, but let's talk about the alerting and eventing. So in the past, to get alerts and alarms, you'd have to query your cluster directly. And just recently we rolled out the alerting functionality, which allows you to define a query against data on your domain, and then you can use to SNS, Slack, or even a custom integration. Now this is really powerful. As I mentioned in the past, you would have had to build up a scheduled event, have a Lambda call to do your work for you. Now it's all baked inside of Elasticsearch, and it makes things a lot easier to manage. So this has come from some of the Open Distro activities, and so over time, Open Distro features and functionalities will make it into the service, and we'll talk about that here. So again, recently, Amazon released Open Distro, which is basically keeping open source open. So we have a project out there that is enabling developers and integrators and architects to start thinking about how many things can I get out there for free, effectively. And so you're able to commit to a GitHub source code base. You're able to contribute to the ecosystem. We're not a fork or a branch of the code. Effectively, we're using the same open source distribution that Elasticsearch 6, 7, and the versions to follow are building from. We're just not presenting through that project any of the paid information or any of the paid features. And so we hope over time that by contributing to this ecosystem, we can build new ideas and completely open source free products. And so I'll talk about a few of those that are coming. First one, again, open source, enterprise grade, community driven. The idea is that the things that you all create eventually can be ideas that we can funnel back into the service. And so we encourage people to work on projects such as security. So what we have right now, if you look at the security features for Amazon Elasticsearch Service, is an integration with Cognito, but it doesn't give you field document level permissions or capabilities to lock things down. The idea is that in Kibana I only get one view of things, but maybe I want to present different screens or different dashboards to people. Maybe I want person A to have access to index 1 and person B to have access to index 2 and 3. And maybe the administrator's access to everything. So the security feature is basically going to give you that integration to control things down to a document and field level. And it's also going to give you the ability to, over time, integrate with LDAP and other third-party providers. And so you can actually see this code right now. It's all out on GitHub. And just look for Open Distro, and you'll be able to see the work in progress as it's being worked on. And these things eventually will make it into the service. Additionally, we're working on an SQL plugin. So many people, if you look at Elasticsearch and you look at the query language, you realize, wow, there's a lot here that I have to learn. But I just came from a database background. Why can't I use SQL? So this is a feature that people have been requesting. This also is out there right now as a plugin, and it's a package that's available for you to use right now if you want to grab it. In time, as I mentioned, things like this, eventually get considered to go into the service. The alerting things I talked about, again, it's open source, so you can take a look at how that's built. If you see something that you'd like to change on it, you can contribute out there, and then we can make these products better. Finally, there is a performance plugin too, which allows you, it's almost like Top, if you've used that in the Linux ecosystem or Unix ecosystem. It tells you different information and different views of what's going on with your cluster, what's happening, the CPU utilization, read throughput, shards that are active in those activities, and give you more in-depth inspection of your Elasticsearch domain. Again, this URL over here will lead you to the project itself, and feel free to hunt around and play around with it. Outside of that, thank you for your time. And what I'll probably do is take some questions. If you want to, we can dig into some of that source code if that sounds interesting. And kind of look at some of the mechanisms that you use for maybe cracking open a file from an object notification that eventually you can put into Elasticsearch. So I'll pause for questions from you because this is your time too, and would love to hear your thoughts on the service or have questions.